So let's do that. So first of all, I'm going to write out these points P and Q again. So maybe we'll put P here and Q here. And I'm thinking of this line through them. I guess it was orange, so we'll leave it as orange. All right. And now I want to compute its slope. And so this will gradually, we'll do this in 2 steps, and these steps will introduce us to the basic notations which are used throughout calculus, including multivariable calculus, across the board. So the first notation that's used is, you imagine here's the x-axis underneath, and here's the x0, the location directly below the point P. And we're traveling here a horizontal distance, which is denoted by delta x. So that's delta x, so-called. And we could also call it the change in x. All right, so that's one thing we want to measure in order to get the slope of this line PQ. And the other thing is this height. So that's this distance here, which we denote delta f, which is the change in f. And then the slope is just the ratio delta f over delta x. So this is the slope of the secant. And the process I just described over here with this limit applies not just to the whole line itself, but also in particular to its slope. And the way we write that is the limit as delta x goes to 0, and that's going to be our slope. So this is the slope of the tangent line. Okay, now this is still a little general, and I want to work out a more usable form here. I want to work out a better formula for this. And in order to do that, I'm going to write delta f, the numerator, more explicitly here, the change in f. So remember that the point P is the point x0, f of x0. All right, that's what we got from our formula for the point. And in order to compute these distances, and in particular the vertical distance here, I'm going to have to get a formula for q as well. So if this horizontal distance is delta x, then this location is x0 plus delta x. And so the point above that point has a formula, which is x0 plus delta x, f of, and this is a mouthful, x0 plus delta x. All right, so there's the formula for the point Q. Here's the formula for the point P. And now I can write a different formula for the derivative, which is the following. So this f prime of x0, which is the same as m, is going to be the limit as delta x goes to 0 of the change in f. Well, the change in f is the value of f at the upper point here, which is x0 plus delta x, and minus its value at the lower point, p, which is f of x0, divided by delta x. All right, so this is the formula. I'm going to put this in a little box because this is by far the most important formula today, which we use to derive pretty much everything else. And this is the way that we're going to be able to compute these numbers.